Hello and welcome to today's video, and I want to thank you guys for following through the series and all your kind comments. To those people who DM me on TikTok, it's great interacting with you. Also, if you find this video useful, remember to like and hit the subscribe button. So up until now, we've done the basic part of our AI. We've just added a print string, like a print function, to our brain, which is our state tree. And just do like a quick recap of what this is. It's basically we have an AI character on the screen. So I'll hit Control and Control E to open it, and basically we have this state tree here, which is like the brain of our character. So it's interesting how AI makes decisions in games, because usually it's what you scripted for it to do. And using the state tree, today we want to just extend it a bit and try and create basic tasks to it. So in today's video, I'm hoping to achieve a move to task. We want our AI to move to a particular location in the map, in our little planned map. The AI can perform maybe an action and maybe return back to where it was. If not so, go to another location and do a specific task. So to do that, we had our character being controlled by the state tree, and our state tree had this only one function that was printing on the screen that the AI is working, which is great. So I'll go ahead and create another state, rather a child state from the root, and I'll name this state. So let me go and create a sibling, which means it will be on the same tree as the root. So I want to create a child, and I'll name the child move to goal. So what I want this task to do is basically find a location on the map and move there straight. Move to the location. So we'll also notice that, okay, let me just continue so that we can make the discovery together. So I'll remove the print string and then compile, because I already know that it's working. So I'll go ahead and create on our state and just go to tasks right here, click add new task, and we can see there are no tasks at the moment, so we're going to create one. To create a task, so just choose a folder in your, let's say in your AI folder. We can say, let me add another folder, because we might have a lot of tasks to do. So I'll say AI tasks, and now right click, go to blueprint class, under all classes, just search task, and you are going to specifically look for state tree blueprint, state tree task, blueprint base. Select that and save it. You can just save it, moving. I'll call it AI task underscore. Let me call it state tree because it's in our system. So I'll call it state tree task stt underscore move. So it's a very general name. we can be moving in different ways, so that's why I've just said move. So I'll open our task and I'll set this up here. We don't need this AI based character anymore. So you'll notice that we don't have anything in our graph, but when you look at our in my blueprints panel, you'll see there are 5 overridable functions. So there is on enter state, on exit state, get description, on state completed, and on tick. So this means that these are the tasks that you're going to use. We can of course like do a lot of other crazy stuff in here, but they are not necessary. So I want first to set my task on the state tree. I'll just go and add the task here, and you'll see it now appears. So I'll click on state tree task move. You can see it's right here. I can compile that, and I want to call my function immediately after I enter the state. So there is this state right here. I'll call it state event enter state. I'll also call event on state completed. I'll also call event on tick. So these are different events. I just want to show you what happens. So these immediately the node fires up, or this child is called, it goes to this specific function. So this is where you want to put your task. So this is how we're going to define our task. So we are going to tell our actor, which is our character, our AI agent right here, that find a place in the map, find a location in the map, and basically move there, right? So on enter state, I'll create a variable just to get a reference of our character, and I'll name it agent, and then I'll change this to character. So it's also important to keep the base character, the default C++ character that comes with the engine. And under category, I'll just change this default here to context. So why have I done that? It's important to remember that we had these context right here in our previous video. We set this state tree to be controlling our base AI character. So we know that basically by passing the context, we can access it all through the move state. So we can just hit this arrow and say actor. So we know that it's linked to this actor. So I don't have to be calling the variables now and again to do casting. What I'll do is I'll get the character itself, and I automatically know that this is our character from the state tree. So to get our character, after getting our agent, I'd like to get the AI controller. So we're basically getting the control of the character. Maybe let's say you can also say the brain, but this is more of making a decision. And then we shall call, after getting our AI controller, we'll just say move to. So there are a couple of different tasks. So there is the navigation, so we can get all of them and just try and compare. So we'll try with the first one, move to actor. That's basically moving to a specific actor. And then we can call the move, another move. There is move to location, which is great. And another one would be move, and there is this simple move to location. And then there is another one here, move, which is a simple move to actor. And then let me just make sure I get all the move, and we'll try to explain them to you. So we can see move to location. We have this already. Statement block detection, and we have this AI move to. You see, so there is different way that you can use all these nodes depending on how you just want to use them. All these nodes basically do the same function, but what I love with this AI move to is that it gives us the conditions. It gives us like the states. It's an async function, and gives us like the state, so we can see if I fail to move. If I can basically get the move result. It's basically like this one, but I'd say for this one it has like fail status. We can know if we can basically track the progress of our movement. So I'll ignore this. I'll get pawn and I'll say AI move to, which gives us the same name. So I'll go ahead and get our agent, drag this here, and then hook that up. So there's also this wall context object. There is a way to like make sure it's not, because right now if we call it, it won't actually work. So I'll try and do like on success and on fail. So on success, I'll finish the task, finish, and then I'll check succeed, and then on fail, I'll check it failed by not checking succeeded. And then this is an async node, so I'll just know if the node fired. So I'll call it and say print, and just a hello will do right there. And the destination, I'll leave it first to be 000. And when we go back to our character, I want, once it finishes the task, I'll say just finish, stop the state tree from working. So don't loop again, because right now if we do, we'll get like a loop. So it will be moving from here and going back to the root, here going back to the root, and we don't want that. We basically want it to have like certain conditions so that we can move to the next thing. So I'll go ahead and hit play, or rather simulate, and you'll notice we get a hello right here, which means our node's working. And the other thing that you'll notice is that our character is not moving. So you might wonder why, but it's fairly simple, because we have our character in the wall, but we don't have the navigation. So we've not set up the navigation of our character. So our character doesn't know. So it will automatically fail. So if I take this and toggle a breakpoint right here, go back and hit play, we didn't get any node fired. So this is not working at the moment. So let's clean up this code and make sure that it's working. So it did print string. However, let me go and check and do this set on state, just call the tree succeeded, compile, come back to our enter state. On succeed, I'll call another breakpoint, and I'll see which node gets fired. So I'll hit play. We can see our task failed. So the reason our task failed is because we tried to move the character, or rather the agent on the screen. We tried to move him, but he didn't have the navigation data, so he didn't know how to get to point 0.000 in our map. So also I'll just try and get an object in the map. So let me get any of the objects, any of the interactables, and I'll pass a reference of it in the task, and I'll say get actor of class, and I'll just say pick. So remember we had our base pick object, and connect these nodes right here, and I'll set this to our target actor. So we can keep the destination to be like 000 as long as we know the actor that we're moving to. So when I hit play, yeah, the task failed because we still don't have our navigation data. So we want to get any actor of the class and move to it, but it basically makes sense for us to get it's important for us to get the navigation of our character. So I'll go to volumes, and I'll say nav modifier volume, volumes, nav mesh bounds volume, not nav modifier, and then so I'll remove the modifier, and then on our volumes I'm just going to edit the dimensions. So I'll make it this long, I'll make it this wide, and that's it. So to see our navigation, you just press P on your keyboard. So I'll press keyboard P, and you can see we have like a green area. So all the green areas are the places that we can go in our map. So I'll save our map, go ahead and hit simulate and play, and then you can see our character is moving straight to a point, and after moving there we can see it now our node goes to succeed. And then let me just remove all of these breakpoints, toggle breakpoints, and remove this one too. Remove the print string, compile, go back to our AI character and reduce his speed. So go to character movement component, search for maximum walk speed and set that maybe to 100. Compile, save, and when we hit simulate, we'll see our character is basically walking to a goal. So it gets like an actor of the class, finds its location and tries to move over there. Is there, and once that's done, the tree succeeds. So it basically tells us that okay, I've completed my job and I'm okay. So we can make like a lot of decisions with this. We can try and add like another state and say let's add another task. So let's move to our goal, and after reaching to our goal we shall do maybe an animation, or we shall pick up something and maybe take it back to the player, right? So I'll just grab our move to. So we'll clean this up. I think I showed you the importance of having these specific AI move to, because we can know when it succeeds and when it fails. We can do like complex decisions based on that. So I want us to move to our goal, and once we are close, we are at the location of our goal, we want to, let's say, pick something, or maybe let's say we want to do an animation, or maybe we just want to get there, jump up and call it like a day. So I'll go ahead and create another child. So I'll say add child state, and I'll say jump, and I'll go back to our tasks. Just duplicate this move to, right click and then say duplicate, and I'll call this set tree jump, and I'll open it again to remove all these because it's another part of the task, and make sure that everything is saved. And we want our agent, once he's close to our goal, he should do like a jump. So we can say jump, because we don't have all the animations right now, because this just represents like what we, if maybe we were to do an animation, we could just call play anim montage. I don't like this one too, so I'll get the mesh. Get mesh, and from here I can call the one that I like, play anim montage. And this is the one that has like all the other nodes. So on completed, we may say finish task. On blend out, we may say just complete the task. So it's more like intuitive to work with. So I'll go back to our goal. It was to get to the location and then hit jump. Then we can basically wait. Task wait delay, or I'll just call delay. I will delay for, let's say, 5 seconds and finish our task. Then check that as succeed. Now we go back to our brain and modify our jump just by adding our task right here. And I'll search for state tree jump. The actor, I will make sure that has been binded, compile, and then we want now the transition right here to be on the state completed, just succeed the tree, and right here we want this to go straight to jump. So I'll just go to my states and I'll say jump. So you can see if I do complete, if I complete moving, I'll do a jump. So we can also tie these to not just completed, we can say let it first succeed, because sometimes we may not reach our goal and that's not what we want. So we want to be specific and say once we succeed at reaching our goal, it's when we can do a jump. If we fail, go back to the root. So just add a new transition, and on task failed, right here on state failed, go back to the root. So I don't know if that makes sense to you, but I hope it does. So we are going to test this really quick, and let us just change the speed a bit. Let's do to 150. Compile, save. When I hit simulate, you can see our character is moving towards our goal. And once there, you can see he did a jump, and we've completed our task, right? So these move tasks could be anything. So you can also get like let's say right now we did get like the base pickup. I want our character to go straight to the player character. So I'll just get player character, and then set this as our target actor. And then when I hit play, you can see the guy is now walking towards me. So I'll try and get away from him, jump a bit, and then I'll wait for him right here. Let me move and face him. Once he's close to me, he can do the jump. Yeah, and that's it. So I think you've got what I wanted you to do. I think it will be good for you to do a task where a character or an enemy, an AI agent, follows a player and attacks him. So that's like your own thing to do. I'm glad you followed through the end, and I'll see you in the next one. Stop.